Okay, today's little mini tutorial will be over 4.7 inverse trig functions. And what I tried to do in class was to set up where these inverse functions really come from. And so we're looking at the graph of cosine x, and we know that it does pass the vertical line test, right? Because it is a function. If you put a vertical line through that, it's going to pass. It means that it's a function. But does it pass the horizontal line test? If we take a horizontal line and pass it through, it hits the function in more than one spot. So it doesn't pass it. So that means technically it doesn't have not technically, really, doesn't have one-to-one correspondence, which means that it does not have an inverse, just like we learned before earlier in the year. So I tried to be a little funny, and the next slide was like, okay, great, doesn't have an inverse, lesson is over. JK. Really, we know that there are inverses for cosine and sine and tan because we have our calculators to prove it. We have the inverse buttons on them. So when we look at cosine, we have to look at a sliver of it that will have an inverse. And so mathematicians decided that we would look for cosine at the sliver from 0 to pi. If we did the vertical line test for the section of this cosine from 0 to pi, it does pass and it will have a horizontal, it will have an inverse. So when we look at cosine of x just from 0 to pi, we can notice some points. We've got this point at 0 where x is 0, y is 1, and we've got this point at well, really, we're looking at the unit circle. So when we've got pi over 2, cosine is 0. When we have pi, cosine is -1. When we have 3 pi over 2, oops, I'm going to stop because we're done with that. We go from 0 to pi. Okay, and so we learned earlier in the year that inverses have flipped xy tables. So if cosine x is 0, 1, then the inverse of cosine is going to be 1, 0. If cosine is going to be pi over 2, 0, then the inverse is 0 pi over 2. And if we've got pi -1, we flip it to -1 pi. So we graph those points, 1, 0, 0 pi over 2, and -1 pi, and we connect them. We could take the time to find more points, but when you connect these points, this is what the inverse sign looks like. Okay, not the red. Let's get rid of that. It's really just what's on there for the blue. And what's important when we look at inverse cosine is looking at the domain. That's, of course, important. We go from -1 to 1, and we're including both -1 and 1. And then with our with our range, we can see that our highest we can go is pi and our lowest is 0, and we're including both of those. So then I stopped in class and I said, okay, look at the top of your note sheet, and this is what's important, the range, because range is saying my answer, right? Domain is what goes in, range is what comes out, and what comes out is our answer, and that's what we're interested in. So anytime we're going to be doing the inverse cosine, our answer is going to be an angle, first of all, and second of all, that angle has to fall between 0 and pi. So you need to memorize that. So that was a quick little lesson on where inverse cosine came from. So we're going to do the same thing with sine. When we look at sine, yes, it passes the vertical line test, so it means it's a function. Does it pass the horizontal line test? No, it doesn't. So once again, lesson's over. No, not really. Mathematicians decided, since the whole function of sine x doesn't have an inverse, they're going to take just a sliver of it. And so we're actually going to look at sine from -pi over 2 to pi over 2, because you can see from -pi over 2 to pi over 2, we do have one-to-one correspondence. One-to-one correspondence, it does pass the horizontal line test. And so we're going to go through this again. If we're just looking from -pi over 2 to pi over 2, we can think about sine. We can think about sine at -pi over 2 when you're looking at the unit circle, and that's going to be where sine is -1. And then we'll look at 0, and sine is 0 at 0. And then we'll look at pi over 2, and sine is 1. So if we're going to get that information from the sine, just tripped over the cord, from the sine graph, and to do the inverse sine graph, we're going to take that table and we're going to flip it. So our inverse sine graph will have these points. And you can see -1, negative pi over 2, that's this point. 0, 0 is this point. And 1 pi over 2 is this point. We could spend our time getting more points and getting that curve, but that is the inverse sine graph. And most importantly for us, the graph gives our brain an understanding of what we're doing. We don't really need to understand the graph as much as we need to understand what the domain and range are. So the domain is, our lowest is -1 and our highest is 1, but most importantly the range. The range is going from negative pi over 2 to pi over 2. So we need to remember this, because when we are doing inverse sine problems and we get an answer, our answer is an angle, and that angle has to fall between negative pi over 2 and pi over 2 inclusive. So we're going to do the same thing with tan. The problem with tan is that you guys you didn't graph it last year, and so we quickly graphed it in class with our knowledge that tan is the same thing as sine x over cosine x. So we just hit up some of the major things on the unit circle, which 0, pi over 2, pi, 3 pi over 2, and the coordinate points. And we thought about what's going on with tan because it's sine over cosine. So we'll make a little table. And with that table, we can see that at 0, so we've got x and y, at 0, sine is 0 and cosine is 1. So that will work, right? 0 over 1, tan will be 0 over 1, which is 0. And then we'll look at pi over 2. Unfortunately, at pi over 2, when we do sine over cosine, we're going to have 1 over 0, which anytime you have 0 in the denominator, it is undefined. So let's just stop here for a second. We can see that the point 0, 0 is right here on our tan graph. We can also see at pi over 2, it looks kind of like a solid line. This should actually be a dotted line. This is an asymptote, which says there's no value for tan when x is pi over 2. And then we can look at pi, and so at pi we see that sine over cosine is 0 over -1, so that equals 0. So that's why you'll see at pi there's another 0. So if we keep going this route of the easy coordinate points on the unit circle, we're just going to keep getting all of our zeros and all of our asymptotes. Let's stop and try to get another point. Let's look at pi over 4. Pi over 4 is important because sine over cosines are going to be equal there, right? Sine is root 2 over 2, cosine is root 2 over 2. Therefore, tan of pi over 4 is 1. And that's going to be right about here, pi over 4. And there's going to be 1. So we could take our time and really plot all of these points, but we'll notice that the same pattern will occur. We'll hit up against a vertical asymptote every pi. Pi from pi over 2 to 3 pi over 2 is pi. So every pi distance, the distance of pi, we're going to have another asymptote. So obviously, it passes the vertical line test because trig functions are functions, but it doesn't pass the horizontal line test. So once again, mathematicians decided that they were just going to look at the tan graph between negative pi over 2 and positive pi over 2. So when they do this, and we already made the xy table, and we kind of already know how this works, but when they switched the xy table, they figured out that this is what the inverse tan graph looked like. And most importantly for our work today, we're looking at the domain, which the domain, why did I put little dots? Because really, well, actually, yeah, those are dots, but these are asymptotes. So the domain actually does go from -1 to 1, but the range does not include pi over 2 and negative pi over 2, so we'll do parentheses for negative pi over 2 and pi over 2. So when you have a problem that involves inverse tan, the answer is going to be an angle, and that angle has to fall between negative pi over 2 and pi over 2. Okay, so that's where we find some of our parameters for when we're dealing with inverse problems. So here we go. The first example, inverse sine of -1. Basically, that means when I see inverse, I think what angle has a sine that's equal to -1. So that's what the inverse said. What angle has a sine equal to -1? So of course I go back to my unit circle and I think about all the main ones. We've got 1, 0, 0, 1, -1, 0, and 0, -1. So it says what angle has a sine equal to -1? Well, this angle here and this angle is 3 pi over 2. So I say, oh, well, that's easy. It's 3 pi over 2. But if you leave it as 3 pi over 2, you're not going to get the right answer. Because when you have an inverse sine problem, your answer is going to be an angle, and that angle has to fall between negative pi over 2 and pi over 2. So 3 pi over 2 is not between that. So we have to rename 3 pi over 2 to fit within the parameter. You'll notice that 3 pi over 2 is a positive angle, and that's when we're going this way to make it 3 pi over 2. But we can name that angle, if we go the negative way, we can name that same angle negative pi over 2. And that's what we'll have to, how we'll have to answer this question if we want to get it right. Once again, it's a, well, when I get to tan, I'll remind you guys. But this is, well, we'll just do it now. In class, I told you it's really an easy way to remember that sine and tan both have the same parameter for their angles. They both had to be between pi over 2 and negative pi over 2. And the way I told you in class to remember it is that maybe your dermatologist told you it's a sin to tan. You don't want to get skin cancer. It's a sin to tan. So sine and tan are together because it's a sin to tan. Cosine, we figured out, I'm just reviewing already. Cosine is going to be, the angles for inverse cosine are going to be between 0 and pi. Okay, so let's move on to the next one, which is arcsine. So arcsine is the same thing as inverse sine. It's just another way to write it. And it still means the same thing. What angle has a sine equal to 1/2? So I think about the unit circle, and I think about the first quadrant especially. And I know the unit circle, and I know that right here, pi over 6, the coordinate points there is root 3 over 2, 1/2. So you can see that sine, when you have sine of pi over 6, it is equal to 1/2. So pi over 6 is my answer, and I have to stop and say, okay, wait a minute, does it fall between negative pi over 2 and pi over 2? And absolutely it does. Any first quadrant angle is going to fall between negative pi over 2 and pi over 2. All right, so this next one, we see that inverse sine of root 3, that should be a root 3 over 2. It's asking what angle has a sine equal to negative root 3 over 2. So I think about a couple of things. I think about, sine is negative. Where's sine negative? Sine is negative in the third quadrant and the fourth quadrant. So the angle that has a sine that's negative lies in either the third or fourth quadrant. But I know inverse sine has to fall in the fourth or the first quadrant. So the third one's out. I know this angle is in the fourth quadrant. So when I look at the fourth quadrant, I have to remember, okay, let's see. I know that sine of, let me switch colors. If I look in the first quadrant and I look at pi over 3, I know the coordinate points are 1/2 and root 3 over 2. And so I know sine of pi over 3 is equal to positive root 3 over 2. When I think about my bow tie, and what goes with pi over 3 is going to be what? 5 pi over 3? And that's going to have the coordinate of 1/2 and negative root 3 over 2. Once again, I could put 5 pi over 3, but I'd have to stop myself and say, wait a minute. If I'm in the fourth quadrant and I have a positive angle, that means I'm going to have to take the time to convert it to a negative angle. 5 pi over 3 is the angle, is a positive angle like that. But we can rename this angle by going in a negative direction. It is pi over 3 away from the x-axis, just like all of the angles in the pi over 3 bow tie. So this angle can be renamed as negative pi over 3, and that is our answer. Okay, so now we're moving on to cosine, and that's supposed to be a square root. So here we go. This really asks what angle has a cosine equal to negative root 3 over 2. So I'm thinking about my unit circle, I'm thinking about my quadrants, and I think, well, cosine is negative in both the second and third quadrants. But then I think about my inverse cosine, and I remember my inverse cosine has to fall between 0 and pi. So we know this angle that we're looking for is not in the third quadrant. So then I think, I always think about first quadrant. It really helps me because I don't have the unit circle in front of me, so it's just in my head. I have to use it out of my brain. So I think about when cosine is equal to root 3 over 2 in the first quadrant, and it's down here at pi over 6. The coordinate points are root 3 over 2 and 1/2. So when I think about that, I'm like, okay, if it asked me what angle has a cosine equal to positive root 3 over 2, I would be done, and pi over 6 would be my answer. But it asked me about the negatives. So we're going to use our knowledge of bow ties. This is pi over 6 short of 6 pi over 6, so it's 5 pi over 6, and its coordinate points are negative root 3 over 2 and 1/2. So there we go. It's 5 pi over 6. Does 5 pi over 6 fall between 0 and pi? Absolutely it does. All right, now let's look at tan and remind ourselves that sine and tan, the answers for these inverse sine and tan problems all have to fall between negative pi over 2 and pi over 2 because it's a sin to tan. Okay, I'm hoping that I repeat it enough and drive you crazy that you'll remember it. All right, so inverse tan of 1 means what angle has a tan equal to 1? So I think about the unit circle, as always, and I think about, the only time, since I remind myself that tan is the same thing as sine over cosine, the only time that sine over cosine in the unit circle is going to equal 1 is at pi over 4. Because at pi over 4, our coordinate points are root 2 over 2, root 2 over 2. So sine over cosine would be, or sine of pi over 4, because sine and cosine are nothing without their angles, right? Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. And when you root 2 over 2 over itself is equal to 1. So what angle has a tan equal to 1? The angle pi over 4 does. And that falls between negative pi over 2 and pi over 2. So we are good to go there. Okay, so this is use a calculator to evaluate the following. I don't have a calculator by me, so I'm going to skip this one. Obviously, we all know how to do that. Let's see, evaluate the following. Okay, here, these weren't on your notes, so let's just go over them just to make sure that you're going to practice them in your homework and all is good. What I'm going to do is I'm going to block off this sign. I'll have to erase it. I'll have to come back and erase it, but I'm just going to look at this, okay? So this says, what angle has a sine equal to 0.12, okay? I don't know what angle has a sine equal to 0.12 because I can't use my calculator, but I do know it's a certain angle. So let's just say this angle, okay, some angle. Now, I'm going to erase this, and it says now, find the sine of that angle. So listen to what this is saying. What angle has a sine equal to 0.12? Well, this angle and its sine is equal to 0.12. So I try to use a little logic there. Some people just go, it's over, it cancels each other out. You don't have to explain it that way. It confuses me. Either way, that is 0.12. Okay, so then we have tan of 5.6. So what I'm going to do is, I'm not 5.6, 5 pi over 6. Making these tutorials at the end of the day after teaching all day isn't always wise, so hopefully I won't make mistakes. So it says find, so tan of inverse tan of tan of 5 pi over 6. Let's see if we can write this. What angle has a tan? Let's see, what angle has a tan of 5 pi over 6? Okay, I'll tell you what, the short way to remember this is we are going to, when we see inverse in a tan, those are going to cancel out and we're going to get 5 pi over 6. Of course, we're not done. Another way to do this, the long way, would be, okay, what is tan of 5 pi over 6? Let's see. Let's find 5 pi over 6. It's right here where cosine is negative root 3 over 2 and sine is 1/2. So let's see. Tan of this, of 5 pi over 6, would be sine over cosine, which would give me, 2's would cancel out, a negative 1 over root 3. I could get fancy and rationalize the denominator, but what my whole point is then I could rewrite this as inverse tan of negative 1 over root 3. And we'd say what angle has a tan equal to negative 1 over root 3? The angle we just did, 5 pi over 6. So it's kind of silly when you work through it logically. Just know that when you do see a sine and an inverse sine right next to each other, that usually, and I say usually, the answer is this, because sometimes they might try to trick us. So usually, in this case, it's true, it's 0.12. In this case, we can write 5 pi over 6, but if we left it there, we'd be wrong, right? 5 pi over 6 is not going to work. Oh, boy, this is tricky, isn't it? Here I am trying to teach you a shortcut, and as I'm teaching you it, it's not working, is it? Can inverse tan be in this second quadrant? No. So let's walk through this. Let's like back it up. Totally back it up. Let's not do any shortcuts. Let's actually work on this. So tan of 5 pi over 6, we just did it. I don't know why I backed it up that much. It was negative 1 over root 3, right? Okay. So now we're going to find the inverse of tan of negative 1 over root 3. So what are we going to do? What angle has a tan equal to negative 1 over root 3? We already found one because the one we were working with, and that was 5 pi over 6. Okay. But we know that we can't use 5 pi over 6 because that's not in the first or fourth quadrant. So we have to think, wait, is tan negative in any other quadrant besides the second quadrant? It's like, yes, tan is negative in the fourth quadrant. So then instead of 5 pi over 6, we're going to use 11 pi over 6 because the coordinates for that are root 3 over 2 and 1/2, negative 1/2. And so tan would be negative 1 over root 3. So this is very tricky, isn't it? So here we are. It's 11 pi over 6. But can we write our inverse tan answer as 11 pi over 6? No. What's a different way to write 11 pi over 6? We can measure it going backwards, and that's negative pi over 6. Whew, that one was a little harder than it looked. We can't just assume, even though it does work out a lot, that just because we have like sine and inverse sine, that 0.12 is going to be our answer. We still need to think these through. If we would have seen this B on the test and canceled out inverse tan and wrote 5 pi over 6, we would have gotten it wrong. All right, so let's look at cosine. So let's look at first, let's block this out, and let's just look at what we have inside. So this says, what angle has a cosine equal to 6? Well, the last time I checked in the unit circle, the biggest a cosine of any angle could be equal to was 1. So is there an angle out there that has a cosine equal to 6? No. So there is no solution to this. We can't even go any further, because if we don't have an angle whose cosine is equal to 6, then we can't find the cosine of it. All right, now we're moving away from the unit circle and more into right triangle trig. If I cover this up, this says find the angle who has a sine equal to 3 over 5. I don't recognize 3 over 5 as a unit circle value, so I know that it's right triangle trig. All right, so find the angle. I'm going to find it. Here's the angle, and I'm going to make it have a sine of 3 over 5. Okay, and then I'm going to complete the right triangle, so I'll have a 3, 4, 5. So when it says find the angle that has a sine equal to 3 over 5, I'm like, oh, I found it. Here it is. This angle has a sine of 3 over 5. Okay, now we'll get rid of this. So now it says find the cosine of that angle. So we know this. We found the angle. It's theta. Now they're asking us to find the cosine of theta. And of course, cosine is going to be adjacent over hypotenuse, so 4 over 5. All right, this one says, we're going to cover up the sine. This says, find me an angle whose tan is equal to -1/2. This is a right triangle trig problem, but it's also a quadrant problem. So the first thing we want to talk about is we're looking for an angle who has a tan that's negative. Where's tan negative? Tan is negative in the second quadrant, and it's negative in the fourth quadrant. Where is inverse tan only allowed to be as far as its answers? The angles always have to be in the first or fourth quadrant. So we know that our angle is not there. All right, so here we go. We're going to do our right triangle trig, knowing that the angle that we find, angle theta, is going to lie in the fourth quadrant. So tan is opposite over adjacent, so we'll have 1 over 2. And if we do Pythagorean theorem, we'll get 1 plus 4 is 5. So our hypotenuse will be √5. All right, so it says, what angle has a tan equal to -1/2? This angle theta does. And we also know it's in the fourth quadrant. So we're going to say, well, that's theta. We found it. And then we see that we have sine. So now we want to find sine of theta. When we look at it, we know that sine is opposite over hypotenuse. And then we're going to stop and say, okay, if this angle is in the fourth quadrant, then sine of this angle is going to be negative. And our answer is -1 over √5. You can rationalize it if you want. Okay, and that's that. I think I'm going to go ahead and zoom. Oh, we don't have our homework. Okay, so for your homework, guys, you had homework problems on the bottom of your note sheet. You don't have to do the vocab. And I also gave you a worksheet for lots of solving inverse problems. I will post that on the blog. You can find it there. Thanks for joining me. See you in class.